Okay, here we go. This is Algebra 2, 1.4, rewriting equations. We're going to start on the back page today, looking at problems 14 and 15. I'm going to zoom way in here. So we've got a Pythagorean theorem of baseball is used to predict the number of wins a team will have, represented by W, when given the number of runs scored, the number of runs the opponent scored, and the total number of games played. That should be played. So solve the equation for W. Well, this should be pretty easy. If we just want to isolate W, we just need to get rid of this T. So this is W divided by T. So we're going to do the inverse operation and multiply by T. This side will cancel. And we need to multiply this whole thing by T. Okay. So now that we've done that, let's take a look at the second part here. We've got, let's see, in 2012, the Yankees scored 804 runs while their opponent scored 668 runs throughout the 162 games. Estimate the number of wins the Yankees had. All right, the actual number of wins for the New York Yankees in 2012 was 95. All right, so let's see here. We've got um, the R is going to be the runs that the Yankees scored. The A is the opponents, and the T is the total number of games, which is 162. So let's go ahead and type or plug this into our formula. So I'm going to go over here because I got more room. Got wins is equal to, um, let's see, R squared. So runs was 804. So 804 squared over 804 squared again, plus 668, that's the opponents, and square that as well, and then we multiply this whole thing by 162. All right, so why don't you guys go ahead and pause the video and solve this out, see what you get. You could probably type this whole thing into your calculator. Otherwise, you can just go ahead and solve the top, solve the bottom, divide it, then multiply by 162. See what you get. All right, I just typed it into my calculator and I got 95.84. So it looks like this prediction model is pretty accurate. All right, moving on. We got number 15. This one has to do with honeybees. So the total number of miles a honeybee can fly in its lifetime is modeled by the equation T is equal to M times D minus 21, where T is equal to the total number of miles flown, M is equal to the miles flown each day, and D equals the lifetime in days. So let's take a look here. Some bees fly up to 55 miles per day, and their muscles can fly a total of 500 miles before giving out and the bee dies. Solve the equation for D and find the total number of days the bees live. So let me just go ahead and rewrite this equation. So I got T is equal to M times D minus 21. All right, in parentheses. So how do I want to undo this thing? I need to isolate D. So the first thing I want to get rid of is this M. I'm going to divide by M on this side. M over M is 1, so it's essentially gone. And now I just want to add 21 on both sides. Add 21. So now these are obviously not like terms, so I'm just going to rewrite this here as T over M plus 21 is equal to D. All right, if you don't like it written that way, we can switch it around for those people who prefer to have the variable that we're solving for on the left-hand side. All right, so here we go. Now let's go ahead and see how long a typical honeybee lives. So let's see, the T is for total number of miles, so that's 500. And some bees fly up to 55 miles per day, so that's going to be our M, miles flown each day. Then we add 21 to that. So let's see, this is going to equal days. All right, so let's type this in, see what we get. I get 30.090909, so I'm going to round that up to 30.1. So it looks like most honeybees only live for about a month. Pretty interesting. All right, that is all we've got for this unit. So you guys give these practice problems a shot. If you need help, come find me. Good luck.